Hello everybody, welcome back. Today's video is talking about integration by parts and finding area between graphs. So both of these are fairly more advanced techniques for using integration or solving some sort of integration problem. So let's go ahead and get started. The first one that we're looking at is integration by parts. Sometimes you'll have a function like this one where it's 3x e to the negative x. It doesn't look too bad, but you can't take the integral directly because they don't have anything that would give a nice closed solution. Also, U substitution, one of our other techniques, does not work either because when you end up using it, it gives you some x's left in the equation or just gives you something very similar after your substitution, so it doesn't help out. Therefore, we use integration by parts. Which the first step of this is you want to find two functions inside your integral, and they have to be multiplied together. So for this one, it would be 3x and e to the negative x dx. Now the dx part is somewhat important. You want to put that on whichever one of the functions is easier for you to integrate, all right? And the other one, it should be easy to take the derivative because you're going to integrate one of them and take the derivative of the other. Whichever one has the dx is the one that you want to integrate. So taking the derivative of f would give you f prime is 3dx, and capital G equals negative e to the negative x. All right. So you notice that I took the antiderivative of one and the regular derivative of the other. Hence why you need to make sure you include the dx and differentiate which one you want. Now, once you have this together, you end up using the two terms without the dx, multiply them together. And then you subtract a new integral, which is based off of your two new items. For this one, our original integral is equal to 3x, which came from here, negative e to the negative x, which is this part here, minus our new integral of negative e to negative x, which is this here, times 3dx, which is this part over this side. All right. And then you would continue to solve that integral itself. So if you have a general term of f times g dx, then you can have this general equation here where f is the f prime and then g is the antiderivative of g. So that's your basic equation for integration by parts. So let's go ahead and take one look at a problem for you to work on. So find the integral of x log x. Now keep in mind, log without anything written is assumed to be base 10. All right, hopefully you've tried something. If you're having difficulty, remember the first step is to find two functions. All right, you should have f equals x and g equals log x. All right, one of the next things you have to make sure you remember is choose which one to put the dx with. Usually want to put it one with it easier to integrate. All right, if you can't figure out which one to go with, I'd probably suggest go with the x because you know what the integral of x is. Log x, yeah, we haven't covered that in class, so you probably don't want to put the dx with that one. All right, so now take the derivative of the one and integrate the other. Remember, you want to take the derivative of the one you put the dx with. All right, hopefully you've done that, and you should get these two functions here. Now, you can also have a dx included here on the outside if it will help you keep things straight, and write the dx up here. I did not put that because I wanted to make sure you choose which one to do yourself. Unfortunately, I can't tell you what the integral of log x is. We don't entirely know. Now, go ahead and take your next step. We multiply the non-dx items. Technically, this would have a dx and this would have a dx. So multiply the non-dx items and then subtract the new integral of the other new items. All right, hopefully you've done that, and you should get something that looks like this with a little bit of simplification. All right. So go ahead and finish this off, and you should get something along the lines of this part here, plus C. All right, hopefully you've learned something about integration by parts. We'll talk about this more in class. Now let's talk about the area between graphs. So when we say area between graphs, we're not necessarily talking about whether the area is positive or negative, because we're just talking area, which is assumed to always be positive. So if graphs cross over each other, then we might not be dealing with what we want to. So let's take a look at a quick example. So y equals, let's go, negative x squared plus 3, enter, and then let's go x squared minus 1. All right, so when we graph these, we're going to get something that we don't want to deal with. So let's go back to our window and set it to the standard. Right? Enter and graph that. So there's our first one. There's our second one. So when we're talking area between, well, there's that area in there. But then if I say up to like 5, you'd also want to include this area here, which would be pretty big. In general, you'll use the formula of integral from a to b of f of x minus gx. Now, to use this, f of x has to be the bigger function for the entire interval a to b. So if this was my f, this integral would only work between this point and this point. All right. If I want to integrate out to 5, then you have to do something better by splitting it up a little bit. So you want to make subintervals where one is bigger than the other for the entire interval. So we can make this subinterval where the top function is bigger than that function for that entire grouping. And then we want to make an interval from here, however far you need to go to the right, and then from here to however far to the left you need to go. And those would be my 3 separate subintervals. And you know, this one would be greater than this function for that entire subinterval over here. This one's bigger on this one, and this one's bigger on this one. All right. Now, once you do that, you want to make 3 separate integrals, one for each subinterval. And then all you have to do is add up all the areas together, and you found the area between your graphs. So whenever you're told to find a problem like this, make sure you look to see where they switch between who's the top and who's the bottom. All right. Hopefully you learned something. I'll see you in class.